So when it comes to graph work, you're most likely to get questions on either velocity or length, electricity, mass with distance as well, and then time. Now later in the video, I'm going to show you how to work with a scale. Before we look at some practical questions that have to do with graph work, I just want to explain a few things to you. I believe that as of now, you know your y-axis and your x-axis. Now in graph work, we actually don't write y-axis and x-axis. That is in interscience. Now you mostly be told of a particular quantity, let's say velocity against time. Now sometimes you would also see plot maybe mass on the vertical and volume on the horizontal. There's this word they also use, ordinate and then abscissa. Okay, so the y-axis, instead of y-axis you see ordinate, or instead of vertical you see ordinate. Then for the x-axis, instead of horizontal, they write abscissa. Now before this video ends, I'm going to take a full question with you and we'll go through everything, including the scale and how to draw, including finding of even the gradient and those instruments that have graduations that are difficult to read, and even how to identify on a graph sheet. So stick with me till the end. So let's try to work around knowing the graduations. Now, some of the graduations are very easy to detect. Some of them are also very difficult to detect. Now, if you scan through this stopwatch, after some time you should be able to get it. So let's try our hands on this question. Now for each of the graduations that you have, 0, 3, 6, and then 9, you want to be able to know the, for example, there's nothing here, there's nothing here. If you see where the dot is. Now, when you scan through, you can identify. But assuming you scan through and the numbers are such that it's very difficult to read, what do? You have to do this calculation that I came up with. So look at, you want to know the graduations for these thick lines, this thick one, and then this thick one. So that's what you are focusing on. And what you do is you pick two consecutive graduations that are close, like 0 here, 3 here, 6 here, 9 here. So assuming I want to pick 3 and 6, so I write my 6, then 3, then subtract the least one from the greatest one. So 6 minus 3 over. Now look at these thick ones that I marked out. These are the thick ones that I marked out. These are the thick graduations that I marked out. Now, in between these graduations that I've marked, I'm marking them because I picked 6 and 3. So 3 and 6. So I have one space here, 1, 2, and then 3. So 6 minus 3 over the number of spaces in between. There are times where you get different numbers. Sometimes you get 5, sometimes you get 10. Just do your division. 6 minus 3 is 3 over 3 equals 1. Now, this tells you something. The places that you marked, it means that before you move to the next, you have to add 1. I hope this is clear. So I would urge you to pause the video and then try, since it's clearer now. So just compare with what you got. So T1 is very clear, it's 3. T2 is what? T2 is 4. T3 is 5. That's 5 seconds. T4 is 6 seconds. Then T5 will be 8 seconds. So this wasn't something that I was actually looking at the whole question. I just wanted to show you how to figure out the graduations by yourself. So we'll pick another one. So this is something that's more challenging to actually figure out. So let's go by the same approach that I used. Consecutive graduations, I'll pick 25 and 50. So 25, 50. So 50 minus 25 over a number of spaces in between. 1, 2, 3, 4, 5. So over 5. So 25 over 5. So 25 divided by 5 is 5. So it means that for every graduation that is close, you add 5. So 5. So this 25, 30, 35, 40, 45, 50, and so on. So pause the video and then try. So if you did everything right, this is what you're supposed to get for the masses. Now let's pick an actual question.
Okay, so we are going to take a question, and you over here you can see an electrical circuit. Then on the left you can see ammeter reading. On the right we have voltmeter reading. Now we are going to be switching between two tabs. So first we are going to read a question. So this is a question. In an electrical circuit arrangement shown above, that is what you saw, the rheostat is adjusted until the ammeter shows the maximum current reading, I0, corresponding to a voltmeter reading, V0. So let's see the I0 and the V0. Okay. So this is the I0, then this is the V0. So you realize that the I0 and the V0 were maximum readings. The rheostat is further adjusted for current values I1, I2, I3, I4, and I5. The corresponding voltmeter readings are also V1, V2, V3, V4, and V5. The figures below show the ammeter and voltmeter readings for the experiment described. Now, these diagrams are actually above, so they're actually not below. Now, I'm going to take you through how to read these values from I0 to I5 and then V0 to V5. And take note that the question said the V0 and the I0 are maximum readings. So the A says read and record the ammeter readings I equals I1, I2, I3, I4, and I5. And the corresponding voltmeter readings V equals V1, V2, V3, V4, and V5. Complete the table below. So in your WAEC exams or question, in answering the question, what you are going to do is you're going to draw the table. Now, if you are answering the question on the same in the same booklet, you would have to just complete the table. Now, this question says complete the table. Assuming you have an answer booklet and a question booklet, you would have to draw again. So the question will be copy and complete. Take notes. Anytime you see copy and complete, you are supposed to draw it again. Vein, my small vein here represents the unit for voltage. Then I, which represents current. The unit of current is ampere. So let's do the reading. Now, if you remember what I taught, I mentioned to you that students really find it difficult to read the smallest values on the instrument that you have. Now, this is the ammeter. Now, we were told initially that I0 is the maximum reading on the ammeter. So let's see. So we have 0, 1, and then 2. Now, what I taught you was to do this. You are supposed to write consecutive values, just two of them. You either pick 1 and 0 or 1 and 2. So let's say I'm picking 1 and 0, and I subtract the smallest value from the biggest value. So I picked 0 and then 1. I'm going to subtract 0 from 1. So 1 minus 0 over the number of spaces between the two readings. So I picked 1 and 0. So in between 1 and 0, now look at the space. Now from this point to this point, you have one space. From this point to this point, you have one space. I believe you get it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to have 1 over 10. Now when I point this on the calculator, I'm going to get 0.1. It tells me that for any one move I make, is 0.1. So from this point to this point, 0.1. So 0.1, 0.2, 0.3, 0.4, 0.5. So I5 is, I believe you can mention it. So 0.1, 0.2, 0.3, 0.4, 0.5. So I5 is 0.5, I believe you remember. Now I4, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. So 0.8. Now this 1. We just add 0.1, so 1.1. Then I2, this one, 1.1, 1.2, 1.3, 1.4. Then we have the last one here. So 1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.7. This is 1.4. Okay, so now we move to the voltmeter. So we're told that V0 is the maximum voltage. So we start from V5. Now we are going to do the same thing for this one too. Now, the closest readings, the consecutive closest readings, 0 and then 0.5, or 0.5 and 1. So I'll go for 0 and 0.5. So 0, 0.5. Now I subtract the smallest from the biggest. So 0.5 minus 0 all over a number of spaces. Look at the spaces. You have 1. So from between this and this is 1. Between this and this is another 1. So 1, 2, 3, 4, 5. So over 5 equals 0.5. Now 0.5 minus 0 is 0.5 over 5. So what are we going to get for this? So the answer is 0.1. All right. So it means this 0, 0.1, 0.2. Now for V5, you realize that it's between 0, 0.1, 0.2, 0.3. It's between 0.2 and 0.3. Now, there are times where the reading will be very close to the mark. So you'd have to go further. And for that, you will still have to use the same approach that I'm showing you. So assuming you want to know the smallest mark for each. Now, this 0, this 0.1. So you are going to pick 0 and then 0.1. Then you are going to count the spaces between the graduations, the smallest graduation. So you are going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this 10. So it's going to be 0.1 minus 0 over 10 equals, so you're going to have 0.1 over 10. Now this is going to give you 0.01. So since this is in the middle, when you do a counting, it's going to be 1, 2, 3, 4, 5. It's on the fifth one. Now, mind you, 0, 0.1, 0.2. So you have 0.2 here. So 0.2 plus, now have in mind this, for each small graduation is 0.01. So 0.01, 0.02, 0.03, 0.04, 0.05. So 0.05, you're going to get 0.25. So V5 is 0.25. Now, if it isn't very clear, I would advise that you reverse the video, just go back a little and watch it again. It's very simple. And I'm going to repeat it for the others as well. So now we go to V4. 0, 0.1, 0.2, 0.3, 0.4. So V4 is 0.4. Then V3, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So in between 0.5 and 0.6 should be 0.55. Then V2. So this 0.5, 0.6, 0.7, 0.7. Then the last one, V1. This 0.5, 0.6, 0.7, 0.8, and 0.9. In between 0.8 and 0.9 is 0.85. 0.85. So we have our values now, and the next question is to plot a graph with V as the ordinate and I as the abscissa. You know, sometimes they'll go like, plot the graph with V as the ordinate here is the vertical, and abscissa here is the horizontal. So the ordinate is also known as the y-axis, and the abscissa is known as the x-axis. So when you're drawing your line, you know, you can either draw on the extreme, what you have on the extreme left, but I always prefer to use this. Now, you don't just draw anywhere. Sometimes the question might not favor you to draw on the line that I actually want to draw on. You have to actually look at the values and determine the scale even before you draw the line. So for V, which is the ordinate y-axis, let's look at the maximum value, 0.85. Now, assuming I want to put my 0 here, so 0, 0.1, 0.2, 0. Now, why am I even using 0.1, 0.2? Why am I not using 1, 2? Because look at the values that we have, 0.3, 0.4, 0.5, 0.7, 0.8. So now, another thing also is your graph should cover more than half of the graph book. So if you realize that your graph is going to be very small, you have to increase your scale. Now, when you take your rule and then you measure one big box, let me call this square, let me call this square one big box. I call this square one big, let me call it one big square. When you measure the dimensions, you have 2 centimeters, 2 centimeters. Now, in every 2 centimeter by 2 centimeter square, you have 4 squares. And when you look at just this small square, just follow what I'm trying to draw. You have about 25 squares in this. Now, for the 2 centimeters, now for this 2 centimeters, you also have 2 centimeters at the vertical as well. So for example, when you hear someone say 2 centimeters to 1 unit, what the person is saying is that when I move every 2 centimeters, I'm going to add 1. So assuming I'm using 2 centimeters to 1 unit for this, I'm going to have 0 here, 1, 2, 3, 4, 5, 6, 7, and so on. Now I can't use 2 centimeters to 1 unit for this because my values don't fall within, or anyway, it's nothing around 1. So I have to use 0 point something. And doing the calculation in my head, I just know that when I put 0 here, I have 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, 0 0.6, 0 0.7, 0 0.8, 0 0.9. Now, 0 0.85 is my maximum value. So 0 0.85 will be taken care of. So on the ordinate or the y-axis, my scale is going to be 2 centimeters to 0.1 units. Assuming I had, let's say 2.0, let's say my maximum value was 2.0. And then I started 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0, 1.2, 1.4. I have to change my scale. Maybe I have to do something like, I have to switch my scale to a point where I would actually have my value on the graph. Now, the more you solve a lot of questions on graph, the more you master it. So my 0 mark will be here. So since I'm ready for the ordinate, I can draw my straight line. Now, always use a long rule. Always use a long rule. And I'll show you why. If you use a short rule, let me just go to a different page and show you something. If you use a short rule, and let's say the short rule can only draw a line to this point. Now you want to continue this line. Then you do this. Now you realize that this line looks crooked. It's not straight. So always use the 30 centimeter rule. Back to the actual work. So 0, 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, 0 0.6, 0 0.7, 0 0.8, 0 0.9. Now, if it was mathematics, I would have to write my y-axis here. But since it's physics and we have V here, so what I'm going to write is, I'm going to write V against volts. So V against volt. Now for the x-axis, my highest value is 1.7. Now, let's say I want to use the same unit. Let's say I want to use the same scale that I'm using for the ordinates for my abscissa as well. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Now, my maximum value here is 1.7. So I can't use 2 centimeters to 0.1 units. So I have to do it 0.2 units. So I'm just checking. 0, 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8. So 1.7 is covered. So I can stick to that. So sometimes you actually even have to shift this line I drew here backward. Now I always do this because I want to have the space to write my whatever quantity I was given. So here I was giving voltage. I want to have the opportunity to write it boldly and then get marks for it. So we said on the abscissa we are going to use 2 centimeters to 0.2 units. So this 0, 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, and 1.8. Now my ordinate, I write the quantity, current against ampere. So I against ampere. Now, you have to indicate your scale on the graph sheet. Okay, so vein against vein, 2 centimeters to 0.1 units. Then I against A, 2 centimeters to 0.2 units. I'm going to plot my coordinates. So vein 1 is 0.85. So this, or the ordinate for vein. So I'll get my 0.8. So 0.85 will be here. So for every small square, this is 0.81 and so on. So this is my 0.85. So 0.85 against 0.17. So this 0.16, 0.17. So where do they intersect? This is where they intersect. So I just make a big dot. I'm going to draw my straight line through. Afterwards, I find my slope as indicated at C. So for me to 0.7. So 0.7 against 1.4. So this is where they meet. The next one is 0.55 against 1.10. So this is 0.55 against 1.10. Now on the abscissa or the x-axis, which we are not using here because of because it's physics, every small square is 0.02. So since we are plotting for 1.10, 1.10 will be the line in the middle. So 0.55 against 1.10. So this is where they will intersect. Then the next one, 0.40 against 0.80. So 0.40 on the vertical, this is 0.4, then 0.80 on the abscissa. So this is where they intersect. And the last V5, 0.35. 0.35 on the vertical. So 0.35 is in the middle between 0.3 and 0.4. 0.35 against 0.50. 0.50 is also between 0.4 and 0.6 on the abscissa. So 0.35 is here, then 0.50 is here. Okay, so we now have our points, and I'll draw the line through at least 3 of the best fits. Now, when I do this, you realize that for the last point that I drew, or I indicated for the V5 and I5, it's not going to pass through, so I'm not going to force it. Now, when I try to draw, I just have it passing through 2 points. But when I go for the first, second, third, and fourth, it passes through evenly. So now this is the main reason why I indicated that you should use the 30 centimeter rule, because if you use the shorter one, which is the 15 centimeter, now when you have your line, let me go to the next page and then show you. Let's say you get your first line this way and you want to continue. Let me try and then make it work and see. Now you realize that it's not a straight line. Good. So you should be convinced enough to get a 30 centimeter rule for your math exams or integrated science final exams. Now it's not compulsory for it to pass through the origin, but if it can pass through, why not? Okay, so it looks like I'm going to have it passing through the origin. Now there's another mistake students also make that I will show on the next page again. And when students are drawing a line, they mostly do this. Now it's not good to do this, because when you do that, it actually makes the thickness of the line uneven, and it looks like it makes it look like an illusion, and then you might think that the line is not straight. So realize that for all the lines I draw, just hold my pencil gently, and then I just take my pencil off. I don't go back and forth. If you think your pencil is not well sharpened, sharpen it well so that whatever you draw on the graph sheet will look more visible. The next thing I'm supposed to do is to calculate my slope. That's the C. Calculate the slope of the graph. Now, we know that for slope, the formula is y2 minus y1 over x2 minus x1. So now, when you are drawing your slope, don't draw the lines on the points. Okay. So when I look at what I have here, when I extend this line down here, then I just want to make sure I give you a straight line. Okay, later I'll tell you why I'm using a pen for the graph. I'm actually supposed to use a pencil. So on the ordinates, my point for the slope, that's y2 is 0.8 minus, on the ordinate again, minus 0.3 all over x2, 1.6 minus 0.6. Very sure. All right. Now, let me say something. Sometimes you see the formula for slope to be y1 minus y2 over x1 minus x2. They all still work. They all work. Now, sometimes you see a student using, for example, over here I use 0.3 and then 0.8. You see a student using 0.3 minus 0.8 and then 0.6 minus 1.6. Now, take note of something. Whether you put y2 first or y1 first doesn't mean anything. What matters the most is, now for the y values, if the value you picked is, now let's compare these two, 0.8 and then 0.3. If I made it 0.8 minus 0.3, I'm also on the abscess. I'm supposed to make it the smallest value, take the smallest value out of the biggest value. Now, let me do it in a different way. So assuming I pick this to be my, I pick the 0.3 to be my y2, 0.3 minus 0.8 over, now assuming I write 1.6 minus 0.6, I'm not going to get my right answer because I put the smallest value first for the y. So I'm also supposed to put the smallest value for the x. So 0.6 minus 1.6. And when I punch on my calculator, let's see what I'm going to get. So 0.8 minus 0.3, I'm getting 0.5 over 1.6 minus 0.6. I'm getting 1. So my slope is 0.5. Now, for 0.3 minus 0.6, I'm going to get negative 0.5 over 0.6 minus 1.6. I'm going to get negative 1. So I'm going to get 0.5 as well because the negatives will cancel out. Now, mind you, the slope always has units. Now, let's look at what we have here. We have volt here and we have ampere here. Back to Ohm's law. V equals IR. Now, what do I actually have? Now, let's look at the Y. Y represents V. Then the X represents I. Let's make R the subject over I over I. So I cancels I. So R equals V over I. Now, I did this to tell you, to show you something, that anytime you calculate slope, it means something. It indicates a quantity. Now, we move to the next question. What is the significance of the slope? So the slope is actually telling you the resistance in the circuit. So that's the answer. D. It indicates resistance in the circuit. We are done with this question.
Welcome to the last part of this video where I'm actually going to use a scale to explain whatever I'm going to do. So I just want to focus on the scale. I wouldn't read any other thing else. So it says measure and record the representative distances D1 to D5 against the given time in the table below. Give the actual distances from the cliff, capital D. So now 1 centimeter to 50 meters means that, you know, on the field, which was, there's a cliff. So every 50 meters of the cliff is drawn as 1 centimeter in a book. So that's what it means. So for a particular time, 1, 4, 6, 8, or 10 seconds, the distance that is represented in book is shown above. That's what you see in your answer booklet. Now this is a device that I can't actually use to measure the actual distance. So we'll just, you know, make some assumptions here. So let's just assume that D1 is 2, D3 is 2.5, D2 is 2.5, D3 is, let's say, 4, D5 is 6.2, then D4 is 6.2, and then D5 will be 10. These are just assumptions. Now, in order to get my actual distance, I have to multiply by 50 meters because the rule you are using, or the rule you will use for a question like this, you're supposed to actually use a centimeter. So whatever you get, multiply by the 50 meters. The last thing I would want to say about this question is that you see that it says measure and record the distances against the given time in the table below. Give the actual distances. So plot the graph with D in meters on the vertical and then T in S on the horizontal. So you're going to plot the time and the actual distance, capital D. Now, after finding your gradient, you are going to have y2 minus y1 over x2 minus x1. Now, your y, which is the distance in meters, and your time is in seconds. Now, there are times where they will ask you that what does the gradient represent? So over here, the gradient will represent meter per second, which is velocity. So take note of that. So anytime you are working with your gradient, always have the quantities that you work with in mind.